Hello friends, good evening and a warm welcome to you in this next session of SX series. आज के सेशन में हम करंट इलेक्ट्रिसिटी पर कुछ क्वेश्चंस देखने वाले हैं. सो लेट्स बिगिन ऑलरेडी एंड बिफोर आई बिगिन कस्टमरी जो है हमारे आपको एक शेड्यूल दिखा देता हूँ इस वीक में क्या क्या टॉपिक्स कवर होंगे. ये ऐसे स्ट्रीम के लिए है एंड दिस वन इज़ फॉर एसएक्स स्ट्रीम, दैट इज़ दिस वन इज़ फॉर योर स्ट्रीम. ऑलराइट, ओके. So again guys, this is the link to our telegram group. You can use this link to become a part of the group. वहाँ पे दूसरे aspirants मिलेंगे आपको. You can discuss your problems with those aspirants. Problems as in the questions that you are attempting, you are having any problems in that, you can discuss that with other aspirants. Okay, so please become a part of this group and make sure that you are part of this JEE channel that we have launched. Please subscribe this channel so that and hit the bell icon also so that you are not missing any videos that we are posting there, and make sure that you are watching our videos. If you like them, please hit the like button. All right, so let's get started. So let's have a look at this question. What does this question say? So there is a circuit in the question. I'll get out of the frame so that you are able to read the question completely. Potential difference across 6 ohm resistor. So I can see a 6 ohm resistance here. All right, so that is given to us as 48 volt and potential difference across A and B is to be found. So seems like a very straightforward question. Complexity कुछ नज़र नहीं आ रही है. Circuit में we have been told that potential difference across these 2 point. Yep. Potential difference across this 6 ohm resistor is 48 volt. So ये 48 लिखा हुआ है. I'm not sure it's very clear or not. Just a minute. Yeah. Alright, and this is 6 ohm. So 6 and 12 they are connected parallelly. तो अगर मैं if I want to replace these two by a single resistor, so what I'm going to do, I'm going to find their equivalent. So when we have two resistances connected parallelly, the equivalent value can be found by using R1 into R2 divided by R1 plus R2. Alright, so the equivalent value of these two will become 4 ohms. Alright, the equivalent value of these two is 4 ohms. Okay. So if I replace these two by a single resistance, that resistance should be 4 ohm. उस 4 ohm के अक्रॉस पोटेंशियल डिफरेंस होगा 48 वोल्ट का. इसका मतलब यहाँ पर जो करंट आ रही होगी जो कि उस सिंगल रेजिस्टेंस क्रॉस करेगी वो होगी 48 वोल्ट डिवाइडेड बाय 4 यानी कि 12 एम्पियर. गॉट दिस? ऑलराइट, वी विल हैव अ सिंगल रेजिस्टेंस हेयर जिसकी वैल्यू होगी 4 ओम. उसके अक्रॉस जो पोटेंशियल डिफरेंस होगा वो होगा 48 वोल्ट. तो उसमें जो करंट फ्लो करना चाहिए वो 12 एम्पियर का करना चाहिए. ठीक है. नाउ व्हाट वी कैन डू, वी कैन फाइंड द इक्विवेलेंट ऑफ दीज थ्री ऑल्सो. ठीक है. फॉर एग्जाम्पल द इक्विवेलेंट ऑफ दीज थ्री, सिंस देयर आर 3 रेजिस्टेंस, लेट्स गो बाय द फॉर्मूला ओनली. 1 upon R equivalent. ऑलराइट, 1 upon R equivalent will be given by 1 upon R1, let's say that is 10, then 1 upon R2 that will be 15, then 1 upon R3 that will be 30. Alright, so 30 will become the LCM here. 30 को अगर हम LCM बना दे, so this becomes what, 3 plus 2 plus 1, which will become 6. So R equivalent becomes 5. Alright, so these three can be reduced to one resistance and the value of that resistance will be 5 ohms. Okay, so 12 ampere will flow through 5 ohm. That means the potential difference that we will have in this region will be 60 volt. 12 ampere into 5 ohm, 60 volt. 48 volt यहाँ है, 60 volt यहाँ है. So ये पूरा कितना हो गया? ये पूरा हो गया 108 volt. Alright. Now 12 ampere is coming like this and 12 ampere also flows through this 8 ohm resistance. So what is the potential difference across this resistance? It will be 12 into 8, which becomes 96 volt. Alright, so as we are moving from A towards B, we witness a potential drop of 108 volt and then sorry guys and then a potential drop of 96 volt. So 108 plus 96 becomes 204. So the answer that we are looking for is 204 volt. Alright, so C option should be the correct one. We had to find the potential difference between A and B and we have found that. Alright, so C should be the correct option as we are witnessing it here. Alright, okay, so I hope ये क्वेश्चन आप लोगों को समझ में आ गया है. ठीक है. किरचॉफ्स रूल का सिंपल एप्लीकेशन था ये. ठीक है. लेट्स लुक एट some other question now. Now the question says, the next question says the total power dissipated in watts in the circuit shown here. So we want to know about the total power that is getting dissipated in this circuit. So we have to understand here that this battery is the only source of energy here in this circuit. This is the only source of energy. So ये जितनी भी energy खर्च कर रही है वही हमें हीट के फॉर्म में मिलेगी. ये सारे रेजिस्टेंस मिलके जो हीट प्रोड्यूस करेंगे वो अल्टीमेटली इसी बैटरी की केमिकल एनर्जी से निकल के आएगी. सो इफ आई फाइंड द अमाउंट ऑफ एनर्जी स्पेंड बाय दिस बैटरी देन आई थिंक वी आर डन. ठीक है. सो हाउ कैन आई डू दैट? लेट्स फाइंड द इक्विवेलेंट वैल्यू ऑफ दीज थ्री. सो दीज टू आर कनेक्टेड पैरेलली. इन दोनों का इक्विवेलेंट हो जाएगा 2 ओम. ठीक है. 6 × 3 मतलब ये दोनों पैरेलली कनेक्टेड है, इनका इक्विवेलेंट आ जाएगा 2 ओम. 2 और 4 सीरीज में कनेक्टेड है, इक्विवेलेंट हो जाएगा 6 ओम. सो ओवरऑल द सर्किट कैन बी ड्रॉन लाइक दिस. वी कैन ड्रॉ द सर्किट लाइक दिस, दैट वी हैव अ बैटरी of 18 volt and this is connected to a single resistance of value. The value would be 6 ohm. So what do you think, guys? In this case, what will be the current flowing through the circuit? Can I say the current flowing through the circuit will be 3 ampere EMF divided by resistance? And if that is the case, then the power developed by the battery or the rate at which chemical energy is getting consumed will be EMF into the current. So 54 watt should be the correct answer. In the options we have 54 watt, so that should be the correct one. Let's have a look at it and we can see that 54 watt is actually the correct answer. All right. Okay, so again simple straightforward questions. Let's move on. Now this question looks like an interesting one. Many of the students get they get stuck in this question. Let's see why. The question says a student measures the terminal voltage. Now what is terminal voltage? It is the potential difference between the terminals of the cell. Okay, EMF is given to be E, internal resistance is given to be R, as a function of current I flowing through it. So let me just explain the situation here, what they are talking about, what the question talks about. Let me just explain that. Let's say we have a battery like this and this battery has a EMF E and it has an internal resistance R, and see, this entire thing is packed. For real batteries this entire thing is packed, which means we cannot join a wire somewhere between these two. Like these are just symbols here. We have a box in which some chemicals are there. There are 2 electrodes and 2 points come out of the battery, and we call these points as positive and negative terminal. So we can only make connections at these points. We cannot go into the battery. So this box tells us that we cannot join a wire anywhere between them. All right. So whatever is the potential difference between these 2 points, that is called terminal voltage or terminal potential difference, and it may be different from the value of EMF. Let's see how. Let's assume that current is flowing in this battery. Just a minute. Current is flowing in this battery like this. All right, let this current be I. Okay, so if I now go by Kirchhoff's loop rule, let me start from here. Let me call this point as X. Let me call this point as Y. So if I start from X, I'm going to write Vx, whatever is the potential at X. Now I'm moving towards Y. So when I cross this resistance in the direction of current, potential falls by IR. So Vx minus IR. Then I'm crossing this battery symbol. I'm moving from negative terminal to positive terminal. So the potential should increase by an amount which is equal to the EMF of the battery, that is E. And now since we have reached the point Y, we can say that the potential is same as the potential at Y. Now this tells us that Vy minus Vx will be E minus IR. That means if we are plotting this terminal voltage, if we are plotting this on y-axis and if we are keeping I on the x-axis, then the equation would be somewhat like this. You can see this, y equal to E minus. The question says this only, we are plotting terminal potential difference as a function of the current I flowing through it. So instead of this I have written y, instead of I have written x. So the equation that we want to consider for answering this question is the equation of a straight line with a negative slope, and the slope is having a value of r, like minus r is the slope. Okay, so y equal to E minus xr. So this is the equation of a straight line with a negative slope. The value of the slope is minus r to be exact, and when x becomes 0, y becomes E. So the y-intercept is equal to the EMF of the battery, and the slope of the graph is equal to the negative of the internal resistance of the battery. So question is asking for that only, the slope and the intercept of the graph. So slope is minus r. So out of these 4 options, only one has minus r. So I'm pretty sure that that should be the correct option, even if I don't worry about the y-intercept. But we have already calculated the y-intercept also, so that is also E. So B option should be the correct one. Let's have a look at it, and yes, B option is indeed the correct one. All right, okay. So Hope you understood this. Let's move to the next question now. Next question says what? Next question says one filament takes 10 minutes to heat a kettle and another takes 15 minutes. If connected parallelly, they combinedly take so many minutes to, so we want to know that. So let's try to understand what is happening here. See, filament of any heater, okay, or any equipment, any instrument that we use in our household, okay, whenever we use them, we apply the same voltage across this. So let's say this is filament 1, it is having resistance 1, okay. So if V voltage is applied across it, the power that this will produce will be V square by R1. So power multiplied by time is, let's say, the amount of heat required to fulfill some objective, okay, to heat some kettle. Here the objective is to heat the kettle. So power multiplied by time will be equal to the amount of heat required to heat the kettle. So first filament took how many minutes? It took 10 minutes. So I can write the power developed by the first filament into 10 minutes. All right, this should be equal to Q. So I can frame this as the first equation. All right, similarly, power developed by the second filament into 15 is equals to the same amount of heat. All right, now when we combine them parallelly, so what happens? We expose this parallel combination to the same potential difference. So each resistance still gets the same amount of potential difference across it. So each filament will produce the same power as it was producing before. So now the total power produced will be given by P1 plus P2. I hope you are getting my point. Let me just draw a figure to emphasize what I am saying. When we are joining these two filaments parallelly, and then if we are exposing them to the same potential difference, then what is happening? Each filament is able to get the same potential difference as it was getting before, which means that it will produce the same power as it was producing before. So this one is producing P1 power, this one is producing P2 power, which means the total power produced by the combination now is P1 plus P2, and let's say it takes T minutes, okay, I've kept time in minutes everywhere. So to generate the same amount of heat. So T is what we want to know. So what we can do, we can write P1 as Q by 10, okay, substitute P as Q by 10, this one as Q by 15. So Q gets, we can pull out Q as the common term, Q will get cancelled out. We will be left with an equation in which only small t will be the unknown quantity, and when we solve this equation, we get the answer as 6 minutes, I believe. Okay, you're going to get this. You can finish the calculation on your own. It's a very simple calculation. Q by 10 plus Q by 15 into T equal to Q. Q gets cancelled. So 1 by 10 plus 1 by 15 into T equal to 1. You solve this equation, you'll get the answer. All right. Okay. And you're going to get 6 as the answer. All right. Okay. So hope you like this question. Let's continue, guys. Let's continue. So now you can see a figure here. Okay. I'll just move out of the frame. I hope the values are clear, or maybe they are a little bit blurred, so I'll just speak them out. I think this should be 5 ohm. I'll write it also. I'll write it clearly also. It may not be so clear. So this is 5 ohms. This is again 5 ohms. This is again 5 ohms. All right. So all these resistances are 5 ohms actually. Okay, so this is 5 ohm and even this is 5 ohm. All right, okay, now let's have a look at the circuit again. So, and this is a 2-volt battery. Now the question says potential difference between points A and B. So this point is A, this point is B. We want to know the potential difference. All right, let's see if we can find current in all the branches or not. Like if you ask me, these 3 resistances are connected in series. So their value will be 15 ohm. The equivalent value will be 15 ohm. And this 15 ohm is connected across a battery of EMF 2 volt. So the current flowing through this branch, the current flowing through this branch is definitely 2 by 15. All right, the current flowing here is 2 by 15 ampere. I'm not writing the unit because of lack of space there. Similarly, again in this branch we have 3 resistances of 5 ohm each, and they are connected in series. So again this branch will have same current like this, flowing like this, and the current will again be 2 by 15. All right, now to find potential difference between A and B, what we can do, we can start from A and we can keep moving towards B, and we can just write the potential changes that are taking place. For example, if I start from A and if I move towards B, all right, through this path, then I'm moving against current. In this branch, current was in downward direction. I'm moving against current through a resistor, so that will result in an increase in potential. So I'm going to put a plus sign here. And how much will be the increase in potential? It will be equal to I into R. So I was 2 by 15, all right, so I into R, that leaves me with 2 by 3, I believe. Okay, 5 by 15, 1 by 3. Next, now I'm moving in the direction of current, so that will result in the fall of potential. How much will be the fall? Current into resistance. I'm taking the combined resistance as 10 ohm. So this will become 2 by 3 into 2. Potential fall across one resistance was 2 by 3. So across two resistance will be double of that. Like, since the resistances are same, the current is same. So I'm doing a direct calculation. Or you can just, what you can do, you can multiply 2 by 15 with 10 and you are still going to end up with this number. Now this should be equal to VB. All right. Now this tells us that VA minus VB should be 2 by 3 volts. So the potential difference that we are looking for, it should be 2 by 3 volts. Let's see whether we have an option like that or not. So A option is the correct one. All right. Okay. So yes, A is indeed the correct one. Let's move to the next one now. So I do believe that you're going to find this question pretty simple. This question says that there are 9 resistors, each of resistance R, and they are connected as shown in the circuit. So I think the corrections are pretty clear to you. The net resistance between A and B, I think that's a very easy question. We want to know the resistance between points A and B. We want to know resistance between this point and this point. So what do? All these points will be at the same potential. All these points will be at the same potential, which means these three are parallelly connected. These three are parallelly connected. These three are parallelly connected. So we can replace this circuit by a circuit like this. All right, this point is A, this point is B, and this resistance will be R by 3. This resistance will be R by 3. This will be R by 3. So this becomes 2R by 3, and 2R by 3 and R by 3, they are connected parallelly. So 2R by 3 into R by 3 divided by sum, which is R. So the result is 2R by 9. Okay, let's, yeah, D option gives me the answer, 2R by 9. So D option should be the correct one. All right, guys. Okay, so I believe you are enjoying these questions. Let's move to the next one. Again, a straightforward question. Let's read what the question says. For a network of resistance shown in the figure, the equivalent resistance of the network between points A and B is 18. All right, so we have to work it in the reverse direction. Like, the equivalent value is given to us and we are supposed to find the value of one of the unknown resistances here. Let's begin. So the equivalent value is given to be 18 ohm, and I can see that whatever equivalent this particular network will have, we are going to add 10 to it, and that will give us the equivalent value of 18. Okay, yep. So the equivalent resistance is 18. This 10 plus something will become 18. So this something must have a value of 8 ohm. I hope you agree with my logic. Whatever, let's say the equivalent value of this entire circuit is X. So X plus 10 is going to become 18. So X should be 8 ohms. All right. So the equivalent value of this should be 8 ohm. All right. Now let's start from this side only. This 10 and this 10, they are connected parallelly. So they should become 5. All right. Now this 5, the single 5 that we are going to draw here, with 10, it's connected in series, so it is going to become 15. So this entire branch is going to end up in 15. All right, this 15, this entire thing, this 15 and this 10, they are going to be connected parallelly. So their equivalent value will be how much? It will be 15 into 10 divided by sum. The sum is 25. So it becomes 6 ohm. All right, so the resultant of these two, like this entire thing, is 6 ohm. 6 plus 10, okay, so that's 16. 16 is in parallel combination with R. So 16 parallelly combined with R gives us 8, okay, which obviously means that R should also be 16 ohm, because only then 16 parallelly combined with 16 is going to end up as 8. So R should be 8 ohms. All right, A option should be the correct one. Okay, hope you enjoyed this one, guys. No, not A option. I said R should be equal to 16, so C option should be the correct one. I'm sorry, my bad. I said 16, but it happens sometimes in the examination also, right? Must have happened to at least some of you that you have calculated something and you have marked something else. Like often students complain of this particular thing, like they lose marks because of this. Probably I lost some marks here. Okay, so let's move to the next question now. What does this question says? This question says a wire of uniform cross-section length resistance is bent into a complete circle. Resistance between diametrically. I think it's a pretty easy question. The wire had a resistance R. I'll just show you. I'm pretty sure that many of you can figure this question out on your own. So this wire had a resistance R. Okay, now if we bend this into the form of a circle, okay, if we bend this into the form of a circle, and we are talking about equivalent value across a diameter, okay, yes, so this particular part will have half the resistance, this particular part will have half the resistance, and the two parts are joined parallelly, so the equivalent value become half. So R by 4 is what we should be looking for. A option should be the correct one. Here we go. All right. Okay, a pretty simple one. I think it was an oral question. All right. Okay. Let's have a look at the next question then. Now this question says in the circuit shown below, the resistances are given in ohms and the battery is assumed ideal with EMF equal to 3 volt. All right. The resistor that dissipates most. Now guys, this is an interesting question, and incidentally it has appeared in the KVPY exam, like it's a previous year question. So okay, so let's talk about this. So the battery is given to us as 3 volt, all right, and some resistances are mentioned here, the values are also mentioned, and we have to figure out which resistance is dissipating the maximum amount of heat. Okay, seems like an interesting question. First of all, understand that you have to just figure out which resistance is generating maximum amount of heat. You don't have to figure the amount of heat that the resistance is generating, right? Like you don't have to figure out how much power one resistance is generating. You have to just figure out which one is generating the maximum power. So let's try to understand it here. See, these two, R1 and R4, I believe it is R4. This is R1, R2, then R3, R4 and R5. So there are 5 resistances. So R3 and R4, they are connected parallelly, all right? And in parallelly connected resistors, the potential difference is same, like potential difference across the parallelly connected resistors, that is always the same. And the heat produced by a resistor, okay, like power developed in a resistance can be written as I square R also and V square by R also. So right now, since V across these two resistances is same, I'm going to use this formula to compare that which particular resistance will produce more power. Alright, so V is same for both, so whichever resistance has a higher value, that will produce lower power. So between these two, 30 and 60, this one has got a higher value of resistance. So R3 will produce less power and as compared to R4. So out of these two, we have rejected R3. This cannot be our answer, as we can clearly see that between R3 and R4, R4 wins, as R4 is producing more power. Okay, now let's try to understand this. If we replace these two by an equivalent value, all right, that equivalent value will be 20 actually. But even if we don't go into the numerical value, see, whatever power comes here, I, okay, in fact we have to go into the equivalent value also, like, yeah, equivalent value is also important. So equivalent become 20. So this I current comes here, there is a single resistance of 20, there is also a single resistance of 20. So I can say that this combination will produce the same power as produced by R5 alone. Tell me whether you agree with this or not. The equivalent of these two is 20. So this 20 is connected in series with this 20. So the power produced by this combination, the entire combination, is same as the power produced by 20, which obviously means that between R4 and R5 is generating more heat, because power developed by R4 plus something else becomes equal to the power developed by R5. So obviously R5 is developing more power as compared to R4. So even R4 has lost here. Okay, R4 is not our answer, because we can clearly see that when we compare power developed by R4 with the power developed by R5, this clearly loses. All right. So R4 is gone. Now we have to compare R5 with others. All right. Now this is 20, this is 20, so their equivalent value will become 40, and we have a 40 ohm resistance here. Now this also means that whatever is the power produced by this entire combination, that same power is produced by this solitary resistance, like this resistance alone. So obviously now again R2 wins when it is compared with R5, so R5 loses. Why? This alone is producing the same amount of power as produced by the combination of these three. All right, so obviously this will produce more power as compared to any other any one out of these three. All right, now this 40 and this 40 becomes 20. All right, so we can say that okay, now these three have lost, so the competition is between R1 and R2 now. All right, now I can clearly see that whatever current comes here, that current crosses through this 40 ohm and a part of it goes into this one. All right, like the current that enters this branch will not be as great as I, it will be something less than I. All right, and the value of the resistance is same here. All right, now comparing by this formula, R is same, I will be more for this one, for R1 current will be more. So when I have to compare these two, this clearly emerges out as the winner. So we have compared all and we now arrive at the conclusion that R1 will be the resistance which is going to produce maximum power. All right, so we are expecting R1 as the answer, and yes, R1 is the correct answer. All right, okay, let's see this one again. I do believe that you're going to like this question, and again this is a previous year question, 2012. In the year 2012 it appeared in the examination. So what does the question says? The question says that a steady current I flows through a wire of resistance R, length L and resistivity rho. The current produces heat in the wire. The rate of heat loss in the wire is proportional to the surface area, steady temperature. So let's try to understand what all is going on here. Okay, situation is somewhat like this. Like let's say this is a wire of length L, radius R, some current is flowing through it, and it has got some resistivity also. So what will happen when the current just begins to flow? As current begins to flow, this particular wire is going to generate heat because it has got some resistance. So it is going to generate heat. As it is going to generate heat, its temperature will become more as compared to the surrounding temperature. So what will happen? There will be an imbalance, like it will start radiating energy. Like it was radiating earlier also, but now it will radiate more as compared to the amount of energy absorbed from the surroundings. All right, so the thing is, when this rod starts radiating the same amount of power as produced in it, ठीक है, जितनी रॉड में थर्मल पावर प्रोड्यूस हो रही है इलेक्ट्रिसिटी की वजह से, उतनी ही पावर जब ये बाहर देने लग जाएगी तो इसके पास एक्स्ट्रा एनर्जी बचना बंद हो जाएगी. इट विल हैव नो, लाइक एनर्जी विल स्टॉप accumulating here. So now the rod will attain a steady temperature. So steady temperature will be attained under the condition that thermal power, all right, thermal power generated should be same as the radiated power. Okay, now P thermal can be written as I square R. I is fixed, R can be written as rho L by A, and it is given that the rate of heat loss is proportional to the surface area. So I can say some constant multiplied by the surface area. Now what is the surface area of the cylinder? Can I write it as 2 pi r L? And when we actually write this, we can see that L gets cancelled. All right, so what do we need to do? The rate of heat loss, the steady temperature of the wire is independent of, okay, now you can see like this the temperature will be independent of the value of length. All right, okay, because length gets cancelled, so it will be independent of the length. All right, so in this question a circuit has been shown. I'll just move to the side. So a circuit has been shown. The circuit shown in the figure, all the resistors are identical. Okay, so we need to find the ratio of current in this branch and current in this branch. All right, so let's see how we are going to do this one. Okay, so see, all the resistances are same. Okay, now whatever current is coming here, this current I is going to get divided into two parts. Okay, all right, so R, 2R and R will become 2R and R, they are connected parallelly, so this is going to become 2R by 3. 2R and R. So 2R and R, if they are connected parallelly, the value will be 2 by 3R. Alright, so the equivalent of these three is 2R by 3, and this R is in series with 2R by 3. So 2R by 3 plus R, this becomes what? This becomes 8R by 3. So this entire branch has become 8R by 3. This is R. So this current gets divided into two parts. The current that moves in this branch, we can write this current as R divided by, like this resistance divided by the sum. So that is R plus 8R by 3 into I. ठीक है, आई थिंक यू मे हैव फेस सम प्रॉब्लम इन दिस वन. ठीक है, ये वाली बात शायद कम लोगों को समझ में आई हो, तो मैं पहले ये समझाता हूँ. ठीक है, देखो, इफ टू रेजिस्टेंसेज आर कनेक्टेड पैरेलली, जैसे देयर आर टू रेजिस्टेंसेज, दिस वन इज R1, दिस वन इज R2, पैरेलली कनेक्टेड है, तो यहां से जो करंट आती है, दिस करंट गेट्स डिवाइडेड इनटू टू पार्ट्स. ठीक है, ऊपर से कुछ करंट जाती है, लेट्स से I1, नीचे से कुछ करंट जाती है, लेट्स से I2. ऑफ कोर्स इन दोनों का जो सम होगा वो I के बराबर होगा. लेकिन अगर हमें I1 लिखना है, यू कैन राइट इट डायरेक्टली. हाउ? ऊपर वाले रेजिस्टेंस में से जो करंट जाती है वो नीचे वाले के प्रोपोर्शनल होती है. ये जितना बड़ा होगा उतनी कम करंट यहां से फ्लो करेगी और ऊपर से फिर ज्यादा जाएगी. मतलब इस I का मेजर फ्रैक्शन फिर ऊपर से जाएगा. सो I1 लिखते वक्त R2 न्यूमरेटर में आएगा और इन दोनों का सम जो होगा वो डिनोमिनेटर में आएगा. राइट, I1 अगर लिखना है, यू कैन जस्ट राइट इट एज R2 डिवाइडेड बाय R1 प्लस R2 इंटू I. सिमिलरली R2 में से जो करंट जा रही है, दैट इज I2. इस करंट को लिखने के लिए R1 न्यूमरेटर में आएगा और सम डिनोमिनेटर में आएगा, इनटू I कर देंगे. सो दिस इज व्हाट आई हैव डन हियर. करंट फ्लोइंग इन दिस ब्रांच विल बी प्रोपोर्शनल टू दिस पर्टिकुलर रेजिस्टेंस. ये रेजिस्टेंस R है और इस पूरे की इक्विवेलेंट वैल्यू जो आ रही थी, मतलब इस पूरे को अगर मैं हटाता, एक सिंगल रेजिस्टेंस बनाता, तो ये सिंगल रेजिस्टेंस 8R बाय 3 होता. तो इसकी तरफ जो रेजिस्टेंस, जो करंट जाती, वो इस तरह से लिखते हैं हम. ठीक है, सो राइट, so the current that goes here is this. Now this current will itself get divided into two parts again. यहाँ पे ये दोनों ब्रांच पैरेलली कनेक्टेड है, तो करंट फिर डिवाइड होगी. तो जो I प्राइम करंट हमें चाहिए, ये करंट जो हमें चाहिए, ये इस रेजिस्टेंस के प्रोपोर्शनल होगी. सो आई शुड बी राइटिंग R डिवाइडेड बाय सम ऑफ दीज टू. ठीक है, ये 2R है, ये R है, तो यहां पे आ जाएगा 3R इंटू I1. I1 कितना है? I1 कितना हो जाएगा? ये हो जाएगा 3R बाय 11R. जस्ट मिनट, डिड आई डू दैट करेक्टली? 2R बाय 3 प्लस R, 2R बाय 3 प्लस R 3. गाइस यहाँ पे 5 होगा, यहाँ पे मैंने थोड़ी गड़बड़ कर रखी है, ये 5 होगा. एनीवेज यहाँ पे 5 लिख देते हैं अब. ठीक है, तो ये कितना हो गया? I1 कितना हो गया? I1 हो गया 3 प्लस 8, 3R, 3 बाय 8I हो गया है ये. ठीक है, तो यहां से वी कैन सी कि ये 3 कैंसिल हो जाएगा एंड R कैंसिल हो जाएगा. I by I prime will become 8. You can see from this equation I by I prime. ठीक है, that is going to become 8. So we have 8 in the option. So A option should be the correct one. All right. Okay. So let's have a look at the next question now. So this question says what? A current of 0.1 ampere flows through 25 ohm resistance. So this one. ठीक है, द करंट इन द 80 ओम रजिस्टर. इस 80 ओम में हमें करंट बताना है. स्ट्रेट फॉरवर्ड क्वेश्चन लग रहा है, क्यों? इसके अक्रॉस पोटेंशियल डिफरेंस हमें पता लग गया. सी 0.1 इंटू 25 इज हाउ मच? या 25 भी क्या, इन दोनों का इक्विवेलेंट भी निकाल लेते हैं. 20 और 60 का इक्विवेलेंट, दिस विल बी 20 इंटू 60 डिवाइडेड बाय सम. सो दिस विल बी 15 ओम्स. ऑलराइट, सो 15 ओम्स यहां पर है, 25 यहां पर है, तो ये टोटल 40 हो गया. ठीक है, 40 इंटू 0.1, दैट विल बिकम 4. सो ओवरऑल द पोटेंशियल डिफरेंस अक्रॉस दिस इज 4. ऑलराइट, नाउ ये जो 0.1 एम्पियर है ये इधर आ गई, इधर जो करंट गई वो कैसे लिखेंगे? सो 0.4 वोल्ट डिवाइडेड बाय 20 ओम, दिस पोटेंशियल डिफरेंस इज 20 ओम. सो द करंट गोइंग हियर विल बी 4 डिवाइडेड बाय 20, which becomes 0.2 ampere. So 0.2 ampere here, 0.1 ampere here. So current flowing in this branch should be 0.3 ampere. By node rule, इन दोनों का सम इसके बराबर होना चाहिए, यही निकालना था हमें. So 0.3 ampere should be the correct one. 0.3 ampere. Alright, it is the correct one. Alright guys, okay, now let's have a look at this question. This question says, if the current through the resistor in a circuit increases by 3%, power dissipated. See, the increase in current is not too great, it's small only. So हम इसमें डेरिवेटिव्स यूज कर सकते हैं. हम पावर को ऐसे लिख रहे हैं, ठीक है. सो इफ आई टेक लॉग ऑन बोथ साइड, इट बिकम्स ln p equal to 2 ln I plus ln R. If I differentiate this equation, we get dp by p equal to 2 di by I plus dr by R. ठीक है. तो अभी के क्वेश्चन में लाइक इफ यू मल्टीप्लाई दिस होल इक्वेशन बाय 100, दिस बिकम्स इंक्रीज इन परसेंटेज इंक्रीज इन करंट प्लस, मतलब ये सारे परसेंटेज में कन्वर्ट हो जाएंगे. सो इफ आई मल्टीप्लाई दिस एंटायर इक्वेशन बाय 100, ठीक है, सो दिस इज परसेंटेज इंक्रीज इन पावर इक्वल टू 2 times द परसेंटेज इंक्रीज इन रेजिस्टेंस इन करंट प्लस द परसेंटेज इंक्रीज इन रेजिस्टेंस. रेजिस्टेंस को तो हम चेंज कर नहीं रहे, हम कह रहे हैं कि करंट 3% बढ़ गई है. तो करंट अगर 3% बढ़ गई है तो पावर जो है वो 6% डबल बढ़ जाएगी. सो इंक्रीजेस अप्रॉक्सीमेटली बाय 6%. व्हाई द वर्ड अप्रॉक्सीमेटली? हमारी कैलकुलेशन तो एग्जैक्ट आ रही है, तो अप्रॉक्सीमेटली वर्ड क्यों किया गया है? हमारी अप्रॉक्सीमेटली वर्ड इसलिए यूज किया गया है क्योंकि ये मेथड ही अप्रॉक्सीमेट मेथड है, ठीक है. ये मतलब आइडियली व्हाट वी शुड हैव डन, आइडियली हमें करंट को आई से चेंज करके ये लिखना चाहिए था, ठीक है. मतलब 10, जस्ट अ मिनट, आइडियली नई पावर ये होगी, फिर हमें डेल्टा पी निकाल के पी से डिवाइड करना चाहिए था, ठीक है. पर तो उससे क्या होता है, एग्जैक्टली 6 नहीं आता, थोड़ा सा डिफरेंस क्रिएट होता. सो ये जो मेथड है यही अप्रॉक्सीमेट मेथड है, इसलिए अप्रॉक्सीमेट वर्ड यूज किया गया है. ऑलराइट, ओके, alright, so now we have a question like this. Okay guys, again this is a previous year question, 2014 में आया हुआ question है ये. Let's see what this question says. Consider the circuit shown below where all the resistance are 1 kilo ohm. If the current of magnitude 1 milliampere, ठीक है, flows through the resistance mark 6, what is the potential difference? See, okay, so सारे रेजिस्टेंस 1 किलो ओम के हैं और इसमें जो करंट है ये 1 मिली एम्पियर की है. सो कैन यू टेल मी द पोटेंशियल डिफरेंस अक्रॉस दिस रेजिस्टेंस एक्स? वेल आई वुड से कि यहाँ पे पोटेंशियल डिफरेंस 1 वोल्ट होना चाहिए, ठीक है. नाउ आई कैन ऑल्सो अंडरस्टैंड दैट सेम करंट विल फ्लो थ्रू दिस ऑल्सो, सो पोटेंशियल डिफरेंस हेयर शुड बी 1 वोल्ट. ऑलराइट, सेम रेजिस्टेंस सेम करंट, सो दिस मीन्स पोटेंशियल डिफरेंस अक्रॉस दीज 2 पॉइंट इज 2 वोल्ट. सो दिस इज 2 वोल्ट, विच मीन्स यहाँ पे करंट भी जो होगी वो 2 मिली एम्पियर आ जाएगी. 1 मिली एम्पियर वॉज हेयर, सो करंट इन दिस ब्रांच विल बी 3 मिली एम्पियर. सो पोटेंशियल डिफरेंस अक्रॉस दिस विल बी 3 वोल्ट. ऑलराइट, सो यहां से यहां तक आने में 3 वोल्ट है और यहां तक जाने में 2 वोल्ट है. सो इन दोनों पॉइंट्स के बीच में पोटेंशियल डिफरेंस हुआ 5 वोल्ट. सो इसमें से जो करंट जाएगी वो आ जाएगी 5 मिली एम्पियर. 5 इधर गई, 3 इधर गई, तो इसमें से जो करंट जाएगी वो होगी 8 मिली एम्पियर, विच मीन्स इसके अक्रॉस जो पोटेंशियल ड्रॉप होगा वो होगा 8 वोल्ट. सो यहां से यहां तक आने में 8 और यहां से यहां तक जाने में 5. सो इसके अक्रॉस जो पोटेंशियल ड्रॉप होगा वो होगा 13 वोल्ट, विच ऑब्वियसली मीन्स कि यहाँ पे जो करंट होगी वो होगी 13 मिली एम्पियर. 13 इधर गई और 8 इधर गई, इसका मतलब यहाँ से जो करंट आएगी ये आएगी 21 मिली एम्पियर, विच मीन्स यहाँ पे जो पोटेंशियल डिफरेंस होगा ये होगा 21 वोल्ट. तो यहाँ से यहाँ तक आने में 21 वोल्ट और यहाँ से यहाँ तक जाने में 13 वोल्ट. तो इसका मतलब इसके अक्रॉस जो पोटेंशियल डिफरेंस हुआ 21 + 13 यानी कि 34 वोल्ट हुआ. सो डी ऑप्शन शुड बी द करेक्ट वन. आया समझ में किस तरीके से वर्कआउट किया है, रिवर्स चले हैं, ठीक है. आई होप यू लाइक दिस थिंग, ठीक है. ऑलराइट गाइस, लेट्स मूव टू द नेक्स्ट वन नाउ. सो 34 वोल्ट इज द करेक्ट वन. ओके, लेट्स हैव अ लुक एट दिस क्वेश्चन. अगेन दिस इज अ प्रीवियस ईयर क्वेश्चन, 2015 में आया हुआ क्वेश्चन है ये. क्या कह रहा है? बल्ब है जिसका रेजिस्टेंस 16 ओम इज अटैच्ड टू सीरीज इनफाइनाइट नेटवर्क विद आइडेंटिकल रेजिस्टेंसेस आर शोन, ठीक है. 10 वोल्ट बैटरी ड्राइव्स करंट इन द सर्किट, व्हाट शुड बी द वैल्यू ऑफ आर? बल्ब डिसिपेट. देखो क्वेश्चन में कह रखा है कि बल्ब अप्रोक्सीमेटली 1 वॉट डिस्प्ले प्रोड्यूस करे, ठीक है. तो इफ दिस बल्ब इज प्रोड्यूसिंग 1 वॉट, ठीक है, इफ दिस बल्ब इज प्रोड्यूसिंग 1 वॉट, ठीक है, इसकी रेजिस्टेंस है 16. सो द करंट फ्लोइंग थ्रू इट शुड बी, I should be writing I square into 16 as 1. So I comes out to be 0.25 ampere. 1/4 आ जाएगा, ठीक है. So this much current should flow. Alright. So that means जो R इक्वलेंट है, मतलब इस बल्ब का रेजिस्टेंस, इस पूरे नेटवर्क की जगह अगर हम एक सिंगल रेजिस्टेंस लगा दें, ठीक है, तो मतलब इस पूरे को तो हटा देते हैं, एक सिंगल रेजिस्टेंस मान लेते हैं R, ठीक है, तो R1 लिख देता हूं मैं, R ऑलरेडी यूज किया हुआ है। तो इन दोनों के कॉम्बिनेशन की वजह से जो करंट फ्लो होना चाहिए ये 1/4 होना चाहिए, ठीक है। दैट मीन्स 10 शुड बी इक्वल टू 1/4 इंटू R इज 16 एक्चुअली, 16 प्लस R1, तो यहां से 40 माइनस 16, R1 की वैल्यू आ रही है 24। सो ओवरऑल हमें ये पता लग रहा है कि ये जो इनफाइनाइट नेटवर्क है इसकी इक्विवेलेंट वैल्यू 24 आनी चाहिए, इसके हिसाब से R कैलकुलेट करना है, ठीक है। सो ओवरऑल क्वेश्चन ये है कि हम एक इनफाइनाइट सीरीज का रेजिस्टेंस कैसे कैलकुलेट करते हैं। इफ यू आर अवेयर ऑफ दैट वी कैन गेट द रिजल्ट, ठीक है। तो अब ये सारी चीज तो मिटाते हैं, ये तो हमारा कंक्लूजन था, मतलब हमने देख लिया हमें क्या करना है, हमें इस इक्विवेलेंट की वैल्यू को निकालकर 24 से इक्वेट करना है। सो हाउ डू वी डू दैट, लेट्स से यहां और यहां इन दोनों पॉइंट्स के बीच की इक्विवेलेंट वैल्यू 24 आनी चाहिए, ठीक है। इस पूरे सर्किट को इग्नोर कर दो अब। सो आई कैन से कि इस पूरे नेटवर्क की वैल्यू अगर x है विच इज 24 राइट नाउ, तो इस पूरे नेटवर्क, इसके आगे पूरे नेटवर्क की भी x ही होनी चाहिए बिकॉज सिमिलर नेटवर्क इज देयर। तो अब हम इस पूरे नेटवर्क को हटाकर यहां पर एक सिंगल रेजिस्टेंस मान लेते हैं 24 का, तो ये 24 और ये R कनेक्ट हो गए पैरेलली, तो ये हो गया 24R डिवाइडेड बाय 24 प्लस R, ये हो गया इन दोनों का रिजल्टेंट। इसमें अगर R और जोड़ दूं मैं तो अब हो जाएगा इन दोनों पॉइंट्स के बीच की रिजल्टेंट वैल्यू विच इज इक्वल टू 24। ऑलराइट, सो दिस इज द इक्वेशन जिसको हमें सॉल्व करके आंसर निकालना है। ऑफ कोर्स क्वाड्रेटिक इक्वेशन बन जाएगी यहां से, ठीक है। क्वाड्रेटिक को सॉल्व करेंगे, द आंसर दैट यू आर गोइंग टू गेट विल बी 14.8, ठीक है। आई हैव ऑलरेडी सॉल्व दिस क्वाड्रेटिक इक्वेशन, सो आई नो कि आंसर मैच कर जाएगा। जस्ट सॉल्व दिस इक्वेशन, यू विल गेट द आंसर, ठीक है। मेथड इसका क्या था, गिवन इंफॉर्मेशन से हमें पहले ये कंक्लूजन निकालना था कि जो सर्किट यहां पे दे रखा है इस सर्किट की इक्विवेलेंट वैल्यू क्या आएगी। वंस वी हैड दैट इक्विवेलेंट वैल्यू, उसके बाद हमें चेक करना था कि सर्किट की इक्विवेलेंट वैल्यू निकालते कैसे हैं। मतलब पहले इक्विवेलेंट वैल्यू हमने निकाली है इस इंफॉर्मेशन से कि इसमें से कितना करंट फ्लो करना चाहिए, फिर हमने इक्विवेलेंट वैल्यू निकाली है सर्किट प्रॉपर्टी यूज करके, उससे आंसर आ जाएगा। ऑलराइट गाइस, सो in today's session I had these many questions for you. I hope you enjoyed these questions. If not all, then at least some of them. I hope you enjoyed them. I would like to inform you about the test series that you can purchase. There are 2 part tests in it, there are 3 full tests in it, so please make sure that you are making use of this test series. And once again I would like to remind you about the Telegram group. You can use this link to be a part of the Telegram group. Alright guys, so on that note I'll finish today's session, and if you have liked the video please hit the like button and subscribe our channel, and you can post your comments in the comment section. Thank you so much for watching this video guys. See you next week. Bye bye, take care.